Hello, everyone, and welcome to this introduction to LLM Studio. I'm going to do an intro of the LLM Studio, and I'm going to guide you through some interesting steps of understanding what LLM is in general. So the idea is to give you an overview of what this tool is capable of, how can you use it, and how can you find it useful, not only for your own professional purposes, but you are going to learn a lot of interesting stuff, I hope. So here we go. Let's start with a question that might have occurred to you already. How does the autofill or the autocorrect function work when writing a message on my phone, for example? Or maybe you have wondered how chatbots are able to answer questions altogether. Well, wonder no more, because you are about to find out in just a moment. And the answer involves large volumes of text data and machine learning models with language processing capabilities. And so this is why today we are going to talk about LLMs, large language models, and what they are, as well as how to create your own application and use it by leveraging the LLM Studio. And so I'm going to explain to you a bit the difference between what the foundational model is and what the fine-tuning model is, so that we understand where does LLM Studio come from. And then I'm going to do a demo, and hopefully you are going to follow along with me to connect to the LLM Studio platform, to launch an experiment, to monitor the experiment, and see what the next steps involved into this process are. So, humans need language to communicate, right? It makes sense that we want to communicate with different devices to speed up our inquiries and get faster answers and solutions. This is where large language models, or LLMs, are extremely useful to learn from billions or even trillions of existing words and to produce new reliable information on any topic or domain. So a large language model is just a type of AI algorithm trained on huge amounts of text data that can understand and generate text. Simply put, it's just that. It learns from a lot of text that we are giving to the model, and it generates text, hopefully in a reliable way that we can use in our own advantage. The programmers define the architecture for the model and the rules by which it will be built. But these programmers do not create the specific rules themselves. This is what machine learning actually comes in. The specific rules themselves are done in a process called training, during which the model, following the instructions of the algorithm, defines the rules itself. So that's interesting, because here we have a machine learning context that takes care of our text data and generates by itself rules that we don't need to program ourselves. Generally speaking, LLMs can be characterized by 4 parameters. So the size of the training data set, and there isn't a universally accepted figure of how large the data set for training is to be. Ideally, and in the best context and in the best scenario, we would give all the books, of all the digital books in the world to this algorithm to learn itself from, all the messages, all the text there is, all the blogs, articles, everything. And so it would be able to take all this information and make sense out of the words that we are given in a way that is going to generate new information based on some statistical rules, a probability of occurrences, of words, of sentences and phrases. So that's just one of the dimensions of the LLMs themselves. The second one would be the cost of training. So here I'm talking about computational power. So the computational power of these large language models is enormous. The biggest the data sets and the biggest the size of the model, the more power it requires and the longer it takes to train. So we can understand that the biggest models that there are taking a lot of time to create an output, just because the algorithms that are based on some mathematical equations are extremely complex. The size of the model would be another dimension. And here, large language models are tens of gigabytes in size and trained on enormous amount of text data. So they are also among the biggest models in terms of parameter count, where a parameter in this case refers to a value the model can change independently as it learns. So if we have some deep learning knowledge, actually this is where parameters can help you understand why the more there are, the better our models are going to be able to predict. And lastly, but not the least, the performance after training. Here I'm talking about how well is the model able to respond to a particular question. The bigger the number of parameters, as I said, the better the large language model is. And for example, chatbots are computer programs that simulate and process human conversation, and they are based on large language models. There's a lot of talk about this. There is a big race happening on the market right now on who is the best at developing these chatbots fastly, efficiently, and with as many parameters as possible. So here you can see a non-exhaustive list of competitors based on the number of parameters. And ChatGPT, as you can observe over here, is a chatbot developed based on a large language model, and it was developed by OpenAI, which you already might know. And OpenAI has reportedly used around 1,000 GPUs, if I'm not mistaken, to train the ChatGPT. And it is estimated that the training process was completed in several months. So it takes a lot of time and energy for these models to get developed. So why not bring the LLM capabilities to everyone in the shape of LLM Studio? And that's not a rhetorical question. The idea is, how are we going to present this? And that's why I'm going to do the demo, so that I show you my own approach to presenting it. So I have three theoretical things to say before we get into the demo. And one of the things is this comparison between what the foundation model is and what the fine-tuning approach would be based on a foundational model. So when dealing with large language models, there are two first main aspects that you need to be aware of: the foundation and the fine-tuning. So the foundation is where a particular model starts to derive relationships between words and concepts. So this would be an open source machine learning model that has NLP capabilities and that has been trained on large amounts of data. An enormous amount of text or data is being trained, as I said, or studied by this algorithm during months. The question that we are asking ourselves if we were a model is, are there any patterns and groups of words that behave in the same way or have a similar meaning? Are we able to make sense out of the information that we get and predict or have an intuition as a model of what would be the next most logical suite of words or sentences or phrases? Yeah, we are able to do that, because the more parameters we have available, the better we are able to have this intuition or understand this pattern. And so foundation models, just to finish this point on foundation models before going to the fine-tuning aspect, they need to be adapted because they serve as a base for new models. And there are numerous approaches to do this, such as fine-tuning, which is actually the second step of our LLM process. So if we want to be general, we are going to have foundation models. But if we want to be specific, we need to fine-tune these foundation models to adapt to our own domain of interest. Here is where fine-tuning comes in. Fine-tuning involves actually adjusting and adapting a pre-trained model. So my foundational model is being pre-trained during several weeks or months. So this is the model that we have been training up to this point. And with fine-tuning, we perform specific tasks and we cater to a particular domain more efficiently. Let's say if I'm going to pre-train my LLM on all the books in the world, I might want to fine-tune my LLM on Dostoevsky. In this second part, what I would do, I would serve to my foundational model only Dostoevsky books. And at the end of this process, I will ask specific questions from all the Dostoevsky books. Maybe it's not the best example, but I'm just trying to show you that actually it is cheaper and it is faster to fine-tune models which have been already pre-trained before. So me as a user, I don't want to take all the books in the world and pre-train them in foundational models. I would love to just use the books that I have at hand in my own domain of activity, let's say marketing, and ask my LL model about those particular concepts, which are just marketing related. That's where I am able as a user by myself without knowing code to fine tune. And this is what LLM Studio does the best. It gives to the human the possibility of actually fine tuning himself or herself. So fine-tuning here, as I said, involves adjusting and adapting a pre-trained model, just to rephrase, to perform specific tasks. So fine-tuning is the process of adapting this foundational model by training it on a smaller, relevant data set. So if we have an HR business case, for example, we could fine-tune a foundational model with just having 2 columns. We would give some information to this LLM model and instructions that are going to be, let's say, resume related. So we are interested to see, for example, what are the main skills of a data scientist. Well, we need to give to our LLM dataset that provides specific information about that in multiple and very varied ways. So this is all we need to do if we want to find out more information about that. And just to give you a nice visual that I took from the internet, which explains very well this idea, once we train the LLM, it can serve as the base for any AI users. So LLMs can generate text for product descriptions, blog posts, or articles. They can also translate business content into different languages. There are a lot of applications. You just see a couple of them here. And so this question and answer that is part of what chatbots are taking care of is just one of the dimensions of the many tasks that actually LLMs can do. So conversational chatbots like H2O GPT are going to fall into this category. They are a derivation of the foundational model that has been actually fine-tuned and are available in a no-code manner for everyone to use. So that's a bit the introduction about it. And now if I'm going to refer a bit more specifically to LLM Studio, well, actually, this is a no-code graphical user interface designed for, as I said before, fine-tuning large language models so that NLP practitioners can fine-tune their large language models easily with no need for coding and with a better flexibility over customization. So you don't need to be a developer in order to fine-tune, and that's what the strength of LLM Studio lies in. So this is a free and an open source tool that is designed for anyone who wants to create and fine-tune their own large language models. And it is designed to be easy to use and accessible to everyone, regardless of the technical expertise. And the pipeline for fine-tuning a large language model is pretty straightforward and similar to a data science project lifecycle. So you would usually import the data on which you want to fine-tune into the LLM Studio. Then you would launch and monitor the experiment. In case you are interested in creating multiple experiments with different settings, you can definitely compare them and see which one gives the best results for your use case. So that's awesome, because if you're not sure with respect to what parameters work the best for your specific data set, actually you can compare the outputs and choose the one that works the best for you. And finally, once decided on the optimal experiment, you can deploy it. Meaning, instead of using the online interface presented, you can take this model offline and you can incorporate it into your own business with respect to data that might be pretty sensitive and you don't want other people to know about. So this is yet another strong point that I find in LLM Studio, which is not pretty current when talking about other LLM platforms there are, because they usually are online and they don't give the possibility to the user to take it offline and to use it in full confidentiality. So that would be like the normal life cycle that we have in data science, generally speaking, and that we also find here when talking about LLM models. Okay, so I wanted to show you some of the salient features here, and I suppose you already know the majority of them. So we are fine-tuning without coding. There are advanced metrics on model comparison. We can share the models, and there's a wide range of parameters that are being involved. So there is a lot of complexity to this application, and by going into the LLM Studio ourselves, we are going to discover some of them. So I hope that you are ready. I am assuming that everyone has a cloud account, and this is mine, a cloud.h2o.ai. Please don't hesitate to connect on it, because what I would love to do now is to actually take a look at the LLM Studio and create an experiment with you. So let's connect on the H2O.ai cloud account. I put the link in the chat, and then we are going to go on the App Store. So please click on the App Store tab and search for the LLM keywords. I have tagged it as my favorite application as for the moment. So here it is. And let's select the app to create our own instance. So I'm going to click on it, and I am guided through another page where I am able to create an instance. I have already 2 of them. And so what I would usually do would be to click on the visit button so that I am directed to the LLM Studio interface. Normally, it takes just a couple of moments to create the instance. And when it is ready to use, you are going to click on the yellow visit button. So now that we are here, we are just a couple of clicks away from making our first large language model. And the screen should look like this, depending on whether or not you have projects that are being queued or finished or running or failed. You might have a different bar chart on the experiment side. And you are presented with some interesting information that give you an idea of what is happening over here. So let's explore a bit the interface. Once you click on this visit button, you arrive on the home page. So this is the home page landing, where you are presented with some technical information about a lot of stuff, such as CPU load, memory usage, disk usage, for example, detailed GPU stats. And here you can see how many GPUs you are using. You can also have up to 8 GPUs, if I'm not mistaken, that are available at the same time. And with each extra GPU, it becomes faster and faster to fine-tune the models. And so I have one as for the moment, and underneath I have the list of the datasets that are in my LLM Studio, as well as the list of experiments. So you see, it's a pretty friendly way of welcoming you. From the home page already, you can see a lot of information. On the Settings tab, just underneath the Home button, if I click on the Settings tab, here you can change the session's default settings, such as connectors and the experiment's initial settings. There is no need for us to change them for the first time, so I like to leave them as they are by default. But in case if you are interested or you want to supply additional information, such as AWS or Kaggle information, projects or tokens, you are more than free to do so. And then click on the Save Settings button. Okay. So let's use an example dataset to train a large language model in LLM Studio. And a dataset is made available to us and prepared by default with when we are first starting working on the user interface. And this is just to demonstrate how the interface works. And I'm able to see it if I'm going to click on View Datasets. So here is the page where I'm going to see all the datasets, the available one, as well as my datasets that I have uploaded to the interface. So once again, to access the list of datasets, you just need to click on the View Dataset button, where you get additional information about the OASST dataset, such as the number of rows that are being used for training purposes, the name labels. Here we have output as a label, and whether we have a validation dataset or not. And in our case, we don't have. And so for each dataset, I can access additional information if I click on the 3 vertical dots from the right side of the row. Here, if I click, it gives me the possibility to create a new experiment right from the View Datasets page. I have the possibility of editing the dataset itself or deleting the dataset if I am interested in doing that. So I can also click on the yellow hyperlink of the name of the dataset to access its contents. So here we see we have 4 columns or features or variables in total: instruction, output, ID, and parent ID. And I can drag and move around the dimensions of the columns so that I see inside what it looks like. So what we are interested in is the instruction itself, meaning the information that the user would write to the machine, and the output, meaning the answer that the user would get from the machine. So here we have a data set that has instructions and outputs, meaning a set of examples of questions and answers that we would simulate for our large language model. So once again, if you want to see more of the text for each cell, the interface is very interactive. You can hover over or drag the column delimiters, just like in an Excel spreadsheet. And so if you hover over, you just have an example of what the answers or what the text looks like. What I really like is this question, for example, if I hover over, is what is the angle maximizing the throwing distance? And the answer, a 45 degrees angle, is the ideal throwing angle for maximizing the distance. In any case, depending on your area of interest, you can have more or less columns, but we are always interested in having at least 2 columns, the instruction and the output, which are extremely important. So if there are questions around, well, how do I have my data set organized in order for me to be able to pre-train myself, to fine-tune myself an LLM model here in LLM Studio, this is the way to do. You will always have 2 columns, one with the questions, question examples, and one with the answers being given to those particular questions. This is what we are indicating to LLM Studio of what types of questions and answers we would like to use for fine-tuning the LLM itself. This is the information that we can find on the sample training data tab, but there are a couple of more tabs. The sample train visualization. This is a tab that is the same as the previous one, but here the text formatting is more interpretable by a human, and we have input text and target text instead of the instruction and the output column names. Then we have a third tab, which is called Train Data Statistics and the summary. And these tabs give you additional information about the descriptive statistics of the instructions and the output values, as well as the data set itself. Pretty cool, right? So now let's go and see how we can import the data set ourselves. So in case you don't want to use the data set that we already have at hand, what you can do is click on the Import Dataset button and go to the source of your choice. So here we have a couple of options. If I click on the drop-down button, you can upload your data set from your PC, from AWS, or from Kaggle directly. And you can also drag and drop your file if you are interested. Please note here, and you have a note mention that this format that we need to ingest if from our own PC and also from the other sources should be only of that zip, that CSV, and that PQ file. H2O LLM Studio expects a file of one of these types with at least two columns. Once again, at least two columns, one being the instruction column and the other one being the answer that the model should generate. You can also provide an extra validation data frame using the same format, or use an automatic train validation split to enable the model performance if you are interested. And so here, just as an example, I can, let's connect on the downloads. I have, I'm searching for, let's say, a train_full.csv text, and I can click on open this file to upload a new file in my LLM Studio. If I click on upload, this is actually uploading, and the upload has been successful. And what I'm able to see here are some additional fields that are going to configure further on my data set. So during an experiment, you can adapt the data representation with the following settings here: the prompt column, which is the column in the dataset containing the user prompt, and the answer column, which is the column in the dataset containing the expected output. Additionally, you have a parent ID column here. This is an optional column specifying the parent ID to be used for chained conversations. The value of this column needs to match an additional column with the name ID. So we are going to, here, we don't have any additional column, but normally you should have a name ID that matches the previous column. And if provided, the prompt will be concatenated after preceding parent rows. So this is a bit more complex than what we are currently doing, but definitely an option, just to be sure that you are tracking actually in the fine-tuning process the suite of questions and answers that are being given. Okay, and all you need to do is to click on continue. There are some additional options, either abort or merge with existing data sets. So I can click on continue to upload a new file. Otherwise, I'm going to use the file that already is available from LLM Studio directly. Okay, so I didn't upload up to the end the file. This was just for demonstration purposes. It is very intuitive how to do it. You just need to specify what is the column that you are going to use as an instruction, meaning the question, and what is the column that you are going to use as an output, meaning the answer itself. In any case, there are a lot of options to import your dataset from different sources, and the simplest way is just to upload it from your local file. I'm going to show you how to launch the experiment. Either click on the three dots here and click on New Experiment, either go to the Create Experiment tab in the navigation bar. So if I click on this, here you can choose the data set that you want to use if you have multiple ones. I just have one, and this is for our fine-tuning purposes. You can also give a name to your experiment if you are interested. Several additional key parameters that are going to be considered in the experiment. So for instance, the choice of the LLM backbone, which determines the model's architecture or neural network architecture. There is a lot of documentation involved in that. There are a lot of options. I won't enter into the technical details because actually as a user, it's not something that you are currently going to deal with. These are default parameters based on your dataset that are chosen by LLM Studio. And for a first experiment, the default settings are very good. Additionally, you can mask prompt labels during training to only train on the loss of the answer in case you are interested. So you have a lot of options here that you can choose to ensure that your training process is effective. There are other hyperparameters like learning rate, batch size, and the number of epochs that can be personalized, which is great because normally developer in Python would just need to code those attributes themselves. And luckily, H2O LLM Studio provides an overview of all the parameters you'll need to specify for your experiment, and the default settings are just right for a first one to play with. We are not going to enter into too many details, as these settings are usually tackled by people who have more knowledge on NLP capabilities and have tested a lot of models and have seen, based on their particular data domain, what works and what not. But please be aware that there are a couple of sections such as general settings, dataset settings, tokenizer settings, architecture settings, training, augmentation, prediction settings, environment settings. So a lot of interesting things to play with. What I would like to mention here in the prediction settings is that you can even choose how to assess the model during and at the end of the fine-tuning process, giving you an idea of the LLM backbone's quality before you start fine-tuning it. So you can choose here from several metrics, if I click on the down drop menu, to evaluate your model through several metrics, including BLEU or BLEU standard metric, or the GPT 3.5 or GPT 4 scores. Nevertheless, because GPT 3.5 or 4 models use open AI models for evaluation, they should not be used for confidential data. And this is an important aspect to mention. That's why BLEU metric will work fine for confidential data that we are not interested in other providers to know about. Additionally, in case you are curious about any of the settings, in the GUI here in the user interface, you have additional information, and you have an I button here with information that you can click on to find additional details. So this is great because in case you are not acquainted with all the metrics there are or all the settings that you can tackle with, even though I wouldn't recommend if you are not knowledgeable of what you're doing, you can learn more about it in the instruction button. We are going to keep all the default settings and parameters in place and click on the button Run the Experiment at the bottom of the screen here, the yellow one. Click on Run Experiment. So now our experiment is being processed. So it is going to start running in the background. And because I don't want to make you wait too much, we already have a finished project that we can look at. For the monitoring of the experiment, well, monitoring is an important part of the training process, and monitoring the training process and the model performance is essential when running an experiment, of course, as any other experiment. And thankfully, the platform offers several ways to do so. And here I'm showing you an example, but I would love to come back to our LLM Studio and click on my delightful project. So here, when I am running the experiment, I have a couple of tabs to choose from. So the first one is the Charts tab, which is a nice visual representation of additional information that we can have with respect to train and validation loss, metrics, and learning rate. And this allows you to easily track your model's performance as it trains. Is there a lot of variability in our epochs or not? How many steps do we have? How fast is my learning rate occurring? Additionally, we have some other tabs that we can take a look at. For example, the summary. So this gives you some statistics, some descriptions about how the model performed itself. Then we have the train data insights, which shows you the model's first batch so that you can verify that the input data representation is correct. And these tabs here, and let me just scroll down a bit more so that you see a bit of an example of what it looks like. It might not always be very intuitive, but that provides insights into how your data is being processed by the LLM and can help identify potential issues early on the experiment itself. Validation prediction insights is another interesting tab that you have, which displays the model's predictions for random best and worst validation samples here. And I can take a look and see what this is all about. These tabs become available after the first validation run and allows you to evaluate how well your model generalizes to new data. And so here you can see, for example, I clicked on best validation samples. You can see just a couple of examples with input text and target text being presented to the screen. And as well, the score, the blue score that I have chosen with the value that estimates how well did my answer perform. Next up, we have logs and config tabs, and they show you the logs and the configuration of the experiments. So you can keep track of any changes made, so you can troubleshoot any issues that might arise in the meanwhile. And finally, after the experiment completes, which is the case here, because actually I am showing you my finished experiment, not the running one, I also have available the chat tab that provides a unique opportunity for us to interact with the trained model and get instant feedback based on it. Here I'm able to see the download logs, download predictions, the model. And what I can also do is to push the model directly to Hugging Face if I want to deploy it. So this was the create experiment, and in the view experiments, just to come back on this idea, you can see all your experiments that have been fine-tuned and their name. You can also change additional information, create new experiments, rename the experiments if you are interested, stop it or delete it. So it is a very good way for you to interact with the outputs and the experiments themselves. Additionally, and that's what I also find interesting, LLM Studio provides a useful feature called Compare Experiments that allows comparing various experiments to analyze how different model parameters affect the model's performance. So here, just to come back to our screenshot, we have two different experiments and we are comparing them on the same chart so that we see which one is a better performer, which is actually the model that we want to work with and to deploy next. And from this, just from this output here, we see that the orange experiment is performing pretty well, better than the blue one, just because there is not such a high variability in the trained batch loss. And so these are things that come with experience. They are already presented here. There are some I buttons that you can take a look at in the output. And while the experiment is running, well, these metrics and these views are constantly being created. And next, once the models are fine-tuned or our chosen model is fine-tuned, well, we can export them from the LLM Studio and even push them to external model repositories such as Hugging Face. So here is where we have this button called Push to Hugging Face Hub. And in case you already have an account, you can actually provide the API key of Hugging Face and export the model so that you can actually deploy it internally, not online, but on your own servers for specific purposes. And so one such example of a deployment of finely tuned LLM Studio model is H2O the model developed and fine-tuned by the H2O.ai team. And I know that currently there are a lot of presentations around this topic. So next up for you would be to maybe attend one of these presentations and learn more about it.